Assalamualaikum and hi everyone. Today we are going to continue with part 4 for our topic 3, which is on numerical computation and expression. In this part, we are going to look at the arithmetic expressions, precedence, and increment and also the decrement operators. What is an expression? It is a data value or a set of operations that compute a data value. For example, say that we have 1 plus 4 times 3. So that is an example of an expression. The simplest expression is a literal value. A more complex expression can have operators and also parentheses. The value that an operator applies to are called operands, or just numbers. There are 5 common arithmetic operators, which are addition, the plus sign, subtraction, which is the minus sign, multiplication, where we use the asterisk sign, division, using the slash, modulus or remainder, using the percentage. When your Java program executes and encounters a line with an expression, the expression is evaluated, meaning that the value is calculated. Let's look at this example. The expression 3 times 4 is evaluated to obtain 12. If we write System.out.println 3 times 4, it will display the multiplication value, which is 12, not 3 times 4. How could we print the text 3 times 4 on the screen? Do you still remember about string concatenation? We need to apply that concept. So, what we can do is, we can rewrite our println method to have a sentence or string within the double quotes to display 3 times 4. We can write it as System.out.println double quote 3 times 4 equal, close our double quote, plus 3 times 4. Do we need to have 3 times 4 in parentheses or in brackets? In this problem, it does not matter because multiplication has higher priority than plus or addition, so it will be done first, even though if we write it with or without the parentheses. Let's look at this code where we have 3 plus 4. Do we need to have it in bracket or not? So when we run this code, the output that we will get is, in the first code, it will have 3 plus 4, which is the string, because we have it inside our double quote, and then it will print out the value 3 and 4 without doing the addition. The second one, the output that we will get is 3 plus 4 equal to 7. So when we use parentheses, we are forcing it to do the addition of 3 plus 4, which is 7, before concatenating it with the string and displaying the result. When an expression contains more than one operator of the same kind, it is evaluated left to right. For example, if we have 1 plus 2 plus 3, that is the same as we have in parentheses 1 plus 2 and then plus 3, which is 6. Let's look at another example. So we have 1 minus 2 minus 3, that is the same as in parentheses 1 minus 2, which give the value minus 1, then minus 3, which will give us minus 4. So this is not the same as 1 minus 2 minus 3 in parentheses, which if we do it that way, it will give us the value 2. So, be careful when doing the calculation and use parentheses where needed, otherwise we might have logical error. This slide shows examples of some arithmetic expressions in Java. As we have seen before, if we have, for example here, rate to the power of 2, we have to write it as rate times with rate, where the symbol for multiplication is the asterisk sign, not x. We can also use maths.power method, where we have seen some examples of it in our previous classes. Let's look at another example. Say that we have 2 times with, in parentheses, salary plus bonus. Normally, we understand that that means 2 will be multiplied with the value of salary and bonus. But in Java, we have to explicitly write 2 multiply with salary plus bonus. If we miss out the asterisk sign, we will not be able to compile the program. The other examples here are showing the importance of using parentheses so that it is easier for us to know and enforce which values to be evaluated first. Integer division with slash. If we do 14 divided by 4, the output that we will get is 3, not 3.5. In Java, when we divide integers, the result is also an integer. The integer quotient of dividing 14 by 4 is 3. The integer remainder of dividing 14 by 4 is 2. Imagine that you are doing a long division. So the value at the top is the quotient, below is the remainder or the modulus value. For any number, if we try to divide it by 0, it will crash the program and cause a runtime error. So we have looked at division. Now let's look at remainder with the modulus sign. So a modulus or remainder, it computes the remainder from a division of integers. For example, if we have 14 modulus 4, it will give it 2. But if we do 14 divided by 4, it will give us the value 3. So the value that we get, it depends on whether we want to have the division value or the modulus, where modulus is the remainder of it. Another example, if we have 218 modulus 5, the answer is 3. But if we do 218 divide by 5, then the answer will be 43. Let's try a few more expressions. What would be the output of this? So we have 45 modulus 6. It will give us 3 because 6 times 7 is equal to 42. So the remainder is 3. If we do 45 divided by 6, we will get 7. What about 11 modulus 0 and also 11 divided by 0? What do you think the output that we will get? Are we able to compile it? For both of this, it will show a runtime error because we cannot divide with 0 and we cannot do modulus as well. Applications of modulus operator. We can use modulus to obtain certain part from a number. For example, how to obtain the last digit 7 from the number 230857. We can do 230857 modulus 10, which the result will give us the value 7. To prove that the value that we will get if we use modulus, so you can see the long division over here, where the last digit is 7. We can use the same concept for the other examples here. You need to find the remainder of the values. For the second one, it says how could we obtain the last 4 digits of a social security number. So we have this number 658236489 and we want to obtain the last 4 digit, which is 6489. So what we can do is we can do the modulus of 10,000 from that number. So we will get the final value, which is 6489 as the remainder. Can the modulus operator help to determine whether a number is even or odd? For example, is the number divisible by 27? We know that for even numbers, such as 2, 4, 6, 8, and 10, they do not have any remainder. Odd numbers, for example, 3, 5, 7, they have remainder of 1. So based on our knowledge about the remainder, we can say that if the number, which is any value, if we modulus it with 2, if the answer is 0, then it is an even number. Otherwise, it is an odd number. You can test it out to see if it's true by looking at this example. if we have 2 modulus 2, it gives us 0. 3 modulus 2 gives us 1. 4 modulus 2 gives us 0. And 5 modulus 2 gives us 1. So we can see the pattern here to determine whether even or odd numbers based on the remainder that it gives. Operator precedence. How does Java evaluate 1 plus 3 times 4? Is it in parentheses 1 plus 3 and only times with 4? Or is it 1 plus in parentheses 3 times 4? Precedence is the order in which operations are computed in an expression. Multiplication operators have a higher level of precedence than additive operators. So if we have multiplication, division, or modulus, they are evaluated first before plus and minus, addition or subtraction. In our example, multiplication has higher precedence than addition, just like on a scientific calculator. So 1 plus 3 times 4 will become 13 because it will do 3 times 4 first, then only add it with 1. To force a certain order of evaluation, parentheses can be used. For example, 1 plus 3 in parentheses times 4 is 16. Spacing does not affect order of evaluation. It is only a matter of style and readability. For example, if we have 1 plus 3 space times space 4 minus 2, it will still do 3 times 4 first because multiplication has the higher priority rather than addition or subtraction. So 3 times 4 is 12, plus 1 is 13, minus 2 is 11. So that's how we get the value 11. Whenever we have operator of the same precedence, for example, we have plus and minus over here, we will always do whichever that is on the left side. So in this 1 plus 3 times 4 minus 2, because plus is the first one on the left, that's why we do the addition first. Precedence rules. The binary arithmetic operators, multiplication, division, and modulus, have lower precedence than the unary operators, plus or minus, plus plus or minus minus, and the exclamation mark, which in Java means not. But they have higher precedence than the binary arithmetic operators, such as the addition and subtraction. When binary operators, which is plus and minus, when they have equal precedence, the operator on the left would act before the operators on the right, as what I showed you in the previous example. We will look at plus plus, which is increment, and minus minus, which is decrement later on. The exclamation mark or not, or the logical negation, it gives the opposite meaning than the initial value. So for example, if we have Boolean value equal to true, and then we have System.out.println value, so that will print out true on our screen. But if we have System.out.println not value, so it will display false. This is because when we have the not or the exclamation mark, it will show the opposite of true. So that's why it displays false. And we know that in Boolean, it only has two values, either true or false. We can also do it the other way around. Say that we have Boolean value equal to false. If we do System.out.println value, it will print out the value false. And when we do not value, it will display true. So it really depends on how you want to represent it. When binary operators have equal precedence, the operator on the left would act before the operator on the right. For example, when we have multiplication and division, they have equal priority, so whichever that appears first will be used. In this example, we have int number equal to 5 times 2 divided by 10. So 5 times 2 will be done first, then only it will do the division. So when we run this code, the output that we will get is the value 1. Even when parentheses are not needed, they can be used to make the code clearer. For example, if we have balance plus in parentheses interest rate times balance, we already know that multiplication will be done first before the addition. So we don't actually have to write in parentheses, but when we write it, it makes the code much clearer to us. Also, spaces can make the code clearer too. For example, if we have balance plus interest rate times balance, so we don't have any space between interest rate, multiplication, and balance. This is still correct, only that it might be harder to see the code and to see the different variables that we have. Spaces do not dictate precedence, it is simply a writing style. To summarize about the precedence rules, the highest precedence is the unary operators, which is the positive and negative values, and then followed by binary arithmetic operators, which are the multiplication, division, and modulus, and at the lowest precedence is the addition and subtraction. Let's look at this example on precedence. We have 1 times 2 plus 3 times 5 divided by 4. So, we will do whichever at the left side first for the highest precedence, which is 1 times 2. And then we will do 3 times 5, and only after that, the value of 3 times 5, which is equal to 15, so 15 divided by 4. So finally, the addition. So we will get the value 5 in the end of it. The same goes for the other example of 1 plus 2 divided by 3 times 5 minus 4, where division will be done first because that is at the left side, and then followed by multiplication, then the addition, and finally subtraction. To test your understanding, you can try and find out the values from these expressions. You can write the expressions in your IDE to check your answers. Real numbers or double. The expressions we have seen so far used integers type int, but Java can also manipulate real numbers with a decimal point, which is of type double. For example, 6.022 or 42.0. The operators plus, minus, multiplication, division, modulus, and parentheses, they work similarly for real numbers as for integers. The division produces an exact answer when used on real numbers. For example, if we have 15.0 divided by 2.0, we will get 7.5. For integers, if we do 15 divided by 2, we will get 7. The same rules of precedence that apply to integers also apply to real numbers. Parentheses has the highest priority before multiplication, division, and also modulus, and addition and subtraction have the lowest priority. In this example, it shows that real numbers also use the same precedence rules as integers, where multiplication will be done first because it is the first operation at the left, then another multiplication, division, and finally the addition. Regarding the real number precision, so consider the following statement. So if we have 35.0 plus 22.4 plus 11.9, and then the whole value will be divided by 3.0. So supposedly we should get 23.1, but instead the output when we run the System.out.println, it will give us 23.0999 and so on. The computer internally represents real numbers in an imprecise way, so some calculations with them are slightly incorrect. Later, we will learn some ways to produce a better output, for examples like above. So now let's look at mixing integers and real numbers. When a Java operator is used on an integer and a real number, the result will be a real number. For example, if we have 3 times 4.2, it will give us 12.6. we can think of it as int times with a double, so it will give us double. So the same goes for division, modulus, addition, and also subtraction. Let's look at this example of mixed type. We have 2.0 plus 10 divided by 3 times 2.5 minus 6 divided by 4. Here we have integers and also decimal points values. As division is at the most left, we will solve it first. 10 divided by 3, both numbers are integers, so we will have the value of 3. Then we have multiplication of 3 times 2.5. So this time, it is an int and a real number 2.5. The result will be a real number, which is 7.5. Next, we have 6 divided by 4, and both are int, so it will be 4. Then we have addition followed by subtraction, and the final value that we will get is 8.5. Specialized assignment operators. Assignment operators can be combined with arithmetic operators such as subtraction, multiplication, division, and also modulus. For example, if we have amount equal to amount plus 5, it can be written as amount plus equal 5. Both of these has the same result. The plus equal is basically a shortcut as we do not need to repeatedly write the variable again. The same goes for minus equal, multiplication equal, division equal, and also modulus equal. However, you have to be careful when mixing with other kind of arithmetic operations. For example, say that we have int count equal to 0, and then we have System.out.println count times equal 1 plus 2. Is that the same as count equal to count times 1 plus 2? What do you think the output would be for these two print line methods? If we run this code, the first one will give us the output of 0, and the second one has the value of 2. Why do you think we have these values? In the first one, when we do count times equal 1 plus 2, as we learned previously, it will solve the right side first. So this is basically count equal to count times in parentheses 1 plus 2. It will do the addition first because addition is at the right side. The second one, which is count equal to count times 1 plus 2, is evaluated according to the precedence rule, which the multiplication first and then the addition. So if you want to use the specialized assignment operators, be careful on what the output that you expect it to have. Other than specialized assignment operators, there are also increment and decrement operators. Increment operator is the plus plus, while decrement is the minus minus. What it meant by increment or decrement is that instead of writing count equal to count plus 1 or count plus equal 1, it can be written as plus plus count. The same goes for decrement, where we can use count equal to count minus 1 or count minus equal 1 or minus minus count. This increment or decrement is used to increase or decrease the value of a variable by 1. So, for increment or decrement, what is the difference of writing the plus plus or minus minus in front or at the back of the variable? For example, we have our variable called count over here. For example, what does count plus plus mean? And what is plus plus count? Similarly, on count minus minus and minus minus count, what does those represent? Count plus plus or count minus minus is post-increment and post-decrement. Plus plus count or minus minus count is pre-increment or pre-decrement. It's easier to explain through code. So let's look at this code where we have int count and then count equal to 0. So we have declared and initialized our variable called count. If we write System.out.println ++ count, the output that we will get is 1. But if we write System.out.println count ++, the output will be 0. So why do we get this different output? This is because for ++ count, the addition is done before the value count is used, meaning that the count is increased by 1, then only the new value will be printed. That's why we call it as pre-increment. For count ++, that is post-increment, the addition is done after the initial value of count is printed on the screen. That's why it gives us the output of 0. But if we have, after that line, we have another System.out.println, and then we want to know what is the value of count, it will show us that count has become 1. This code here shows what I meant by adding another System.out.println and printing out the value of count at the last line. We are not doing any addition. We simply want to know the value of count. If we run it, the output that we will get is 1, 0, and 1, which means after printing the count ++ statement that displays 0 shown by the purple highlight, count is then increased by 1. The same goes for decrement, count minus minus, and minus minus count. This code shows for decrement, where instead of having ++ count and count ++, we now have the minus minus count and count minus minus. The output that you will get is -1, 0, and then -1. Let's look at more examples. Say that we have int m equal to 4, and then we have another variable called result of type int result equal to 3 times ++ m. Remember that from the previous slide, if we have ++ at the front, the increment will happen first before any other operation. So this means the result is basically result equal to 3 times 1 plus m. So we will get 15. Let's look at an example of post-increment. So similar as before, we have int m equal to 4, and then we have int result equal to 3 times m++. So m++ means the increment happens after the calculation. So basically, result is equal to 3 times m, where m is equal to 4. So result equal to 3 times 4, we will get 12. And m is only increased by 1 after that statement. So if we have our System.out.println, at the last line, our m will show the value of 5, not 4. If you are still confused about ++m and m++, which is the pre-increment and post-increment, run this code where it will show you all the values at all of the steps. For the ++m case, m current value is 4. Then, since we have ++m, m is then increased by 1 before the variable result is calculated. So result is 3 plus 5 equal to 15. And m now has the value of 5. If you look at this code, I have m equal to 4, where I comment it as initialize or reassign value. I have to do it because the line before, I have already done ++m. So if I don't reassign the value again, then the final result would be something else. Similar as the previous code, over here I have changed from ++m to m++. If you run this code, you will get the output as shown here, where m current value is 4, result of 3 times m++ is 12, because we get from 3 times 4. And finally, the value of m after the post increment, it will show as 5. To summarize, we have looked at assignment statements and expressions, precedence, and increment, and also the decrement operators. So that's all for part 4.